In this problem, we're going to be finding the inverse of each of these functions and finding the domain and range of the original function and the inverse function. So we know that the domain of the original function will be the range of the inverse function, so that should help us out a bit. We also know that the domain of the inverse function will be the range of the original function. So let's fill in the things that we know we can fill in immediately. Are there any restrictions to a linear function? There are no domain restrictions. So we can go from negative infinity to infinity. Therefore, the output is also going to be from negative infinity to infinity for the inverse. So now let's calculate that inverse. We're going to start by replacing f of x with y. And now because our domain and range are flip-flopped, our inputs and outputs are flip-flopped, we're going to change our y into x and change our x into y. And now we're going to solve for y. Add 2 to both sides. Divide both sides by 3. And finally, rewrite this expression in inverse notation. Are there any domain restrictions on this function? There's no x's in the denominator, so there are no domain restrictions. So it goes from negative infinity to infinity. Therefore, the range of our initial function is also negative infinity to infinity. Let's check out problem number 2. Now we do have a domain restriction because we have a rational function with x in the denominator. So x cannot be 0 in our domain. So we're going to write our domain from negative infinity to 0 with a soft bracket union 0 to infinity. This means that our inverse's range is also going to be negative infinity to 0 union 0 to infinity. Now let's calculate our inverse function. We'll rewrite our function in terms of y. Then we'll exchange our x's and our y's. And now we'll solve for y. Add 2 to both sides. And take the reciprocal of both sides. Now we can see that there are domain restrictions on the inverse as well. X cannot equal a negative 2 or we'll divide by 0. So this domain goes from negative infinity to negative 2, union negative 2 to infinity. Therefore, the range of our original function will also be negative infinity to negative 2, union negative 2 to infinity. In our last example, we have a square root function. So we know we have a restriction here. What is inside the square root has to be greater than or equal to 0. So I'm going to find our domain using a small calculation below. Subtract 1 from both sides, and we know that x has to be greater than or equal to negative 1. So we're going to have a hard bracket, negative 1 to infinity. That will also be the range of our inverse function. Now the range of our function must be a positive number because the square root is a function. Therefore, we restricted the domain, and we have to have outputs. I should say we restrict the range. We have to have outputs that are positive. So not the inverse. The range of the original function, the outputs are going to go from 0 to infinity. I'm not going to write down the inverse range until we actually calculate it. So we are going to rewrite this in terms of y, switch our x's and our y's, square both sides, and solve for y by subtracting 1 from both sides. Now we can rewrite this in inverse function notation. So the domain has to match the range of our original, otherwise there are no domain restrictions here. So the domain of the inverse, the only numbers that we can put in are non-negative numbers.